In this video, we will cover simplifying rational expressions. So, first of all, what are rational expressions? Rational expressions are quotients of two polynomials p and q, so are expressions of the type p of x over q of x, where p and q are polynomials. For example, I don't know, 3x squared minus 2 over x, or 5x to the power 101 minus 10x to the power 99 plus 3x to the power 2 over 7x to 32 plus 3x squared, and so on and so on. Simplifying rational expressions is the correct way to simplify a rational expression is very important, as we're going to see very early in calculus 1 when we're going to be dealing with limits. So it's very important that you guys refresh how to do this properly. Okay, so let's start with very simple example. Simplify the expression 3x squared over 9x. Okay, of course this is extremely simple, but let's go over the basis. So here, what can we have constant 3 over 9, right? So 3 over 9 is equal to 3 over 3 squared. So we cancel one factor of 3 and one factor of 3 in the denominator, and we're left with 1, not 0. Be careful not to make that mistake, over 3. And then we have the variable x. I have x squared over x, so x squared divided by x is simply x. Okay, so what's left? We have 3 divided by 9, as we said, is 1/3. I have a 3 in the denominator, and then x squared divided by x, I'm left with x. Okay, so we can simplify the numerator and the denominator, or we can cancel the numerator and the denominator as long as they have common factors. Okay, now be careful. The next example, x plus 5 over 5x times x plus 5 squared. Okay, be careful. You cannot observe neither x nor 5, neither x nor 5 as factors, because they're not. Okay, because factors, they have to be multiplied, right? So I can cancel this. I can neither cancel x with x, nor I can cancel 5 by 5. Why? Because if I want to cancel, simplify the numerator, I have to observe the whole expression as a factor. So I can cancel this as long as I have a factor of x plus 5 in the denominator, and that is the case. We have it. So cancel the whole thing here with one factor of x plus 5 in the denominator, and I'm left with 1 in the numerator. So if you cancel, if I divide x plus 5 by x plus 5, I'm left with 1, right? A divided by a is 1, not 0. Be careful about that. And we're left with 5x times x plus 5. Okay, let's do few more examples here. Let's do more factors. 3x squared minus 1 times x squared plus 1 times x plus 1 squared over x squared plus 1 times x plus 1. That's enough. Okay, so here I give you this example just to be able to differentiate between x squared plus 1 and x plus 1 squared. Few of you will make this mistake in Cal 1, so that's why I'm writing it here. X squared plus 1 is not equal to x plus 1 squared, because x plus 1 squared is x squared plus 2x plus 1. Okay, obviously this term 2x is not here. Okay, so what are the factors that we can cancel? Okay, so x squared plus 1, I don't have it here. Here I have x squared plus 1, and I have the factor of x squared plus 1 here, so we cancel those. And here I have x plus 1 squared, and here I have only x plus 1. So I cancel one factor of x plus 1 in the numerator with the denominator, and I'm left with 3x squared minus 1 times x plus 1. Okay, usually here we'll have to, we're going to, so far the examples that we did, the problems, the rational, the numerator and denominator in the rational expressions were already factored out, but that's not going to be the case. So we have x squared minus 6x plus 5. Okay, you should be able to recognize right away that the numerator is difference of squares, so that's x squared plus 5 squared, which factors out in x plus 5, x minus 5 times x plus 5. Okay, now what would be the fast way, the good way to use the factor theorem? So I wonder whether I have x minus 5 or x plus 5 in the denominator. In order to have a factor of x minus 5 in the denominator, right, 5 should be 0 of this polynomial. So let's just check. Let's just simply put here 5. 5 squared is 25, minus 6 times 5 is 30. 25 minus 30 is negative 5, plus 5 is 0. So if I plug here 5, I get 0, which means that x minus the number that I plugged in our case that was 5, x minus 5 is going to be one of the factors of the denominator. And then you can see in the previous videos how quickly to finish factoring this polynomial. With what do you have to multiply x to get x squared? Simply x. With what do I have to multiply negative 5 to get positive 5? Times negative 1, and you're done. Cancel the common factor. The answer is x plus 5 over x minus 1. Okay, next problem, 2x to the power of 4 plus 4x cubed minus 6x squared over 4x to the power 5 minus 4x to the power of 4. Okay, the first thing that we can notice in the numerator and in the denominator that the terms have common factors. So let's clean these expressions a little bit. I can factor the constant 2 for each term in the numerator, but also the biggest common factor in terms of x is x squared, so I can factor x squared also. And I'm left with what? With what do I need to multiply 2x squared to get 2x to the power of 4? Just x squared. With what do I need to multiply 2x squared to get 4x cubed? That's just 2x minus 3, because negative 3 times 2x squared is negative 6x squared. Now the common factor in the denominator is 4x squared, and we're left with x minus 1. I'm sorry, 4x to the power 4. I factor 4x to the power 4, and I'm left with x minus 1. Okay. First of all, I can cancel 2 and 4. I'm left with the constant 2 in the denominator. I cancel 2 factors of x in the numerator and 2 factors of x in the denominator, and I'm left with x squared. And here I have x minus 1. The question is, can I factor this polynomial, right? Or can I factor x from here? No. Can I factor x minus 1 from here? Well, let's check. If by plugging 1 here I get 0, then x minus 1 indeed is going to be a factor of this polynomial. So 1 squared is 1, plus 2 times 1 is 2, 1 plus 2 is 3, 3 minus 3 is 0. So for sure, since 1 is 0 of this polynomial, x minus 1 is going to be one of the factors. Finish factoring. X times x is x squared, plus 3 times negative 1 is negative 3. Cancel out the common factor, and your answer is x plus 3, oops, over 2x squared. F. Okay. 1 plus minus x cubed over x squared minus 1. Okay, in the denominator have difference of squares, so that's x plus 1 times x minus 1. Okay, and here I have difference of cubes, and if I factor this out, I have 1 minus x times 1 plus x squared, right? I'm just going to, I used here the formula a cubed minus b cubed, that is equal to a minus b, a squared plus ab, sorry, plus b squared. Okay, is there a common factor here? Well, no, this is 1 minus x, this is 1 plus x squared. Here I have x plus 1, and here I have x minus 1. But you have to notice here that these two, right, are just a multiple of negative 1, right? So basically they differ by multiplication of negative 1. So basically, if I factor negative 1 in the numerator, if you factor negative 1 in the numerator or pull out the negative sign, you're left with x minus 1 from this factor here, right? So this factor is identical as this whole thing, right? If you drop the, if you FOIL this negative in here, you'll get negative x. Negative times negative 1 is positive 1, so negative x plus 1 is 1 minus x. And then copy everything else. And then you can simply cancel the common factor. Just don't forget the negative sign here. Negative 1 plus x squared over x plus 1. Here, the answer that I just wrote is absolutely incorrect. Why? Because if you read this numerator, has nothing to do with the numerator in the previous step. This says negative 1 plus x squared. So again, I'm going to say be very careful about the parentheses. Okay, so the previous answer without the parentheses was completely incorrect answer.